Yes, hello everyone. Happy New Year. So, what's the first thing that we should do on a New Year's Eve? It should solve a lead code. Obviously, it's the lead code problem of the day, 66, which is plus one. So yeah, it's a lead code was feeling generous for New Year's Eve, and it was and it's an easy problem. So yeah, question says you are given a large integer represented by an integer array digits, where each digit I is the ith digit of the number. The digits are ordered from most significant to least significant in left to right order. The large intervals does not contain any leading zeros. Increment the large integer by one and return the resulting array of digits. So here, let's take this test case. So the test case says that digits are 1, 2, 3. Basically, see, here the question is we have to deal with a very big integer. So if we are dealing with a very big integer, we cannot represent it in an integer or long because integer with can only represent 32 bits. So 2 raised to the 32 or around 10, it would be around 10 raised to the 9. And same for long, it should be 10 raised to the 18. So if we have to deal with bigger integers, there are two ways to deal with it. One is to store it in a string because string can be of any size, right? So we can store it in a string of all the digits. One way is this, the other way is vector. That we store a vector of digits basically. Here digits are represented as integer. Here, like we can see, this is an integer which is 1, 2, 3. Now you can say, okay, we can store this in an integer, but what if it was a very big integer, like integer of 100 digits, then obviously we cannot use int, we have to use this vector or string. So okay, this is one integer. Now the question asks us to increment its value by 1. So how do you increment it by 1? 1, 2, 3 plus 1 is 1, 2, 4, and then just finally we have to return this into an output. So a couple of things that will come to your mind is, okay, we can convert this back to an integer, but again, this will overflow for a big integers like 100, then integer overflow you will get. So that won't work. What is the other way? That let's keep them in a vector of int and let's increment it in a vector of int. So how does incrementing it works? Like if we have this, let's say we have a slightly trickier one. We have 199 and we have to increment it by 1. So that is we add here 1, then this becomes 10, right? 9 plus 1 is 10. Then we carry forward this one and then we basically carry forward this one. So and then this again becomes 10. Again we carry forward this one. This becomes 200, right? This is a simple arithmetic addition we were taught in school. So this becomes 200 and finally we can return this 200 in a vector of integer. So how can we do this in a vector of int? Because right now how we do integer addition is just we do integer plus integer. This operator is already defined. Now we have to define this plus operator for our case, right? For a vector of int and an integer where the integer is given to us as 1, right? So you have to manually handle these carries and all of that. So how will you do that? Well, let's say the digits are 1, 9, 9, and we have to add 1 to it, right? So how will you do that? You will add 1 to the last digit. Then you will check if, okay, if this digit becomes 10, because 9 plus 1, it will become 10. Then you will carry forward this one, and then again you will repeat this. So 9 plus 1, 10. And then again you carry forward this one, and this becomes 200, right? This is one way. The only trickier thing of this test case would be if all of the digits were 9, triple nine, and then you are adding 1. So then what will happen is 0, carry forward, 0, 1, 0, and sorry, and this becomes 1. One second. So this is trickier because now you have to add another new digit, right? That was not in the integers array. So how can you do this? Is how I implemented it. You can obviously traverse the array from back to front and then add it. The only problem I was seeing in traversing it back to front is what if you have to add a new digit? Because see, vector does not allow us to pop in the or push in the front. It only allows push in the back. So that would be tricky that you will have to create a new vector which has like let's say this has n size. So if you were implementing traversing from back to front and adding, if you have to add a new digit, you'll have to create a new vector of n plus 1 size, push all the n values here, and then push the new value at the front. So that you can do. Obviously it's not that tricky, but what I did is basically I reversed the digits. So here it doesn't really matter, but for like 199 I reversed it to 991 and then I added 1. So I add 1 here, 0, 1, 1, 0, 1, 2, and I keep adding till there is a carry, right? And if now in this case, why it's better is because see, if I have to add one, this is basically how we do this in Urdu. We are reading from right to no, we read the right left to right only, right? In maths we read right to left. Why it says maths in Urdu? Okay, that's besides the point. Okay, yeah. What was I saying? Yeah, we'll add here 0, 1, 0, 1, 0. Now we have to add a new digit. Now we can just push it into the back, and we also have to reverse this again before returning it. So let me show you the code of how I implemented this. So as I said, I first of all reverse all the digits from beginning to end. Okay, why is this so zoomed in? Let me make this better. Yeah. And then I add in the first digit because we have reversed this. So this is actually the last digit, but I added into the into the first digit 1. Then I traverse over all the digits after 1. So this is adding into the 0. Now I can traverse from 1, and I check if the before digit is greater than equals to 10, that is, it is giving me a carry. I will reduce its value by 10. I will add into the current digit 1. Else, if it is not 10, then there is no addition that we need to do, else we can just break, right? So basically what I'm doing is, see, if I have to do 991 plus 1, this is 199 in the reverse form, right? So I will add it, store this digit 10, then I will go to this digit. Now I will check, okay, is the last digit greater than equals to 10? If it is greater than equals to 10, that is, it is giving me a carry. So I have to decrement this by 10 and add into my own, yeah, add one to my own. Again, this becomes 10. Now I go to this digit. Then again, I check, is the previous digit greater than equals to 10? Yes, it is greater than equals to 10. So I can remove this and add it into my own. So this becomes 200 in the reversed form, right? Which makes sense. So I can continue doing this. Now the only check that I have to do is if the last digit becomes greater than equals to 10, that is I have to add a new digit, which is this case, right? I was adding 999 and then yeah. So okay, triple nine, adding this becomes 10, this 0, 0. Now this becomes 10, right? So I have to deal with this 10. So that is basically the last digit of my digits becomes greater than equals to 10. In that case, I will just do this. Basically, add a new digit. So how we do this is we decrement the last digit by 10 and add a new one. And finally, we just reverse digits and then return digits. So this works. The time complexity is O of n being the number of digits here. Yeah, thank you for watching. If you were able to understand anything, give me a like and subscribe. All of those things. Bye.